Okay, so we can do some practice here and draw some equivalent fractions. So I want you to first of all draw the equivalent fraction in the fraction strip here. So I've given you the initial fraction 3/12, okay, and we want to figure out what the equivalent fraction is in terms of fourths, and then what does that look like? How is that grouping going to look like? Okay, and I want you to show the times divide factor. So if I want to write the equivalent fraction here, this is going to be 3/12 the same as 1/4. Okay, and we can see that I have a times factor here, times by 3. So, and I know that if I go in the opposite direction, I can divide by 3. Okay, and I want you to show these factors for all of these problems. Okay, for your homework as well. I want you to make sure that you're showing this times and divide factor, and I also want to see the direction. Okay, whether you're timesing this direction or dividing in this direction, right? And again, we can times this way and divide this way, and it's entirely consistent. So when I show this, I can show this as 1/4 by doing it in chunks of 4. Okay, there's 1, 2, 3, 4 chunks. Okay, those 4 chunks make up my whole. Okay, just gonna make it a little bit darker on that. And the one chunk that's been shaded in, okay, this is the one piece in the numerator that makes up the part. Okay, what about this next one? Well, I can see that I have from here to here, I have a times factor. Now, if I want to find a times factor, I can always divide. If I divide, I always find a multiplying factor. So 24 divided by 8 gives me a times 3 factor. I'm going to go in the same direction, so I'm going to times 3 as well, and I get 9/24. Now try to understand how that times 3 shows up. I have 3 pieces out of 8 parts whole. I want to make it 9/24. Well, that times 3 is in fact, doing groups of 3 for my parts. Okay, so I have my 9 parts, and if I do groups of 3 for the whole, I end up with 24 parts that make up my whole. So here I end up with I want to reduce this fraction from 12 9/12. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 12 pieces whole. And I want to make this into, well, I'm going to divide by 3. And I'm going to divide by 3 here. Okay, so I end up with 3/4 as my new fraction. Okay, so I'm going to do this in groups of 3 then. Okay, so groups of 3, groups of 3, groups of 3. That makes my 9 parts into 3 parts. Another group of 3 makes my 12 parts into 4 parts. Okay, so then the last one here, I want to do times by 4, times by 3, times by 3. So I want to do this in groups of 3. There's my parts, my 9 parts, sorry, my 12 parts. And then you can see that I have my 1, 2, 3, 4, 5, 6, 7, 8, 9 parts that make up my whole. Okay, I can do this as well. But there's my whole. I'm going to highlight my one whole piece. Okay, so there's my 9 parts that make up the whole. Okay, so there's my 12 parts over compared to the 9 parts. So now this is what we call an improper fraction, but that's okay. I have my ratio done properly. I have more than one. 12 parts shaded, 9 parts that make up my whole. And notice that the yellow highlighted is the 9 parts that make up the whole. Okay, so we want to reduce fractions. We can also do this, show these times and divide factors as actual multiplying factors in the actual equation. So here I have 15 over 20. I can rewrite 15 as 5 times 3, 5 times 4. and I can cancel out these because I know that if times on top of 5 and divide on bottom, divide by 5, well, times 5 divide 5 cancels out. So I'm left with 3 over 4. And notice that's the same thing we were doing before, except before we were writing it like this, times 5, or sorry, divide by 5. Should write that properly, divide by 5, divide by 5, okay? But now instead of writing it on the outside like that, we're going to write it right in there as a factor. So for this one here, we want to recognize the common factor. Now we can use multiple common factors if you want to do this into primes, but we don't really need to if you can recognize the common factor. So here I recognize my common factor is going to be 6. So I end up with 6 times 4 on top, 6 times 5 on bottom. That's going to simplify to 4 over 5. And again, it's really important to show that. Okay, this is an idea that you need to show those red factors there. For 56, what's the common factor? Well, I'm not positive. I think it's going to be, I know they share a common factor of 4. Okay, and when I divide by 4, I'm going to be left with, in this case, 8, which I can write as 2 times 4. Oh, sorry, 2 times, this is going to be 14, so it's going to be 2 times 14, 2 times 7. Okay, on the bottom I'm going to be left with 4, like that. Oh, I see I share a common factor of 2 here, so I'm going to write this as 2 times 2. Okay, and we can do this in multiple steps if you like, but in the end, we want to be able to cancel out common factors. Okay, and this simplifies to 7 over 2. Okay, so then if we recognize that there's a common factor of 8 here and 8 here, we can have done it as one factor, but we could have also done it as 2 factors like I did here. So again, if you can identify common factors, bigger common factors, it's easier we do less steps to do this. So here, I know this is 3 times 7, this is 3 times 5. Well, 7 and 5 is nice because they're prime, and I know that I don't have to go any further. Okay, so I have 3 times 7. 3 times 5, so I'm going to be left with 7 on top, 5 on bottom. Okay, so there's my simplified fraction. And please leave these. Notice I'm leaving these as improper fractions. I actually prefer you leaving things as improper fractions. For the next one here, again, make sure you're showing your common factors. It looks like this one shares a common factor of 4, at least 4. Okay, so when I do that, I'm going to end up with, okay, this is going to be 6 on top. 78 divided by 4 is going to, oh, this one does not share a 4. It shares a 6, doesn't it? Okay, so I'm going to look at the 6. See, I'm going to share a common factor of 6 here, and I'm going to be left with 6 times 4, okay, and 6 times 13. Well, 13, again, 13 is prime, so this is actually kind of nice because we know that we can't go any further and to find common factors. Okay, and again, if you want to find the 6, what we could do is just test it by dividing. If you want to find out the leftover factor, anytime you want to find a multiplier, we divide. So 78 divided by 6 gives me the 13 there. So if I want to find a multiplier, I divide. That's really important. Okay, you divide to find multipliers. Alright, so this one here, I think this one shares a common factor of 11. Okay, so 11 times 2 on top. And I think this one, well, I don't know actually what this one says. Let's try this on a calculator. So on my calculator, if I test 11, that's the nice thing about having an 11 is that we know that it's prime. We can't break it down any further. Okay, so 11 times 33 is going to be equal to 363. Okay, so I found that by dividing. I'm not really good with my multiples of 33, but since I can find that number by division, I just divided. So then I can cancel my times 11 on top, divide 11 on bottom, and they cancel out. Okay, they undo each other. Okay, this idea of undoing is really important. Okay, so the last one here, this is 60 and 222. Well, I don't know if this shares anything more than a 2. Okay, but we can try. So 2, 2, and this is going to be 111. Now 111 is divisible by 3. So when I do this, I end up with 30 here. I can actually simplify this even further. Okay, so I'm actually going to do this in 2 steps because I think this is, it starts getting a little bit harder. So 30 over 111, I can rewrite that. They share a common factor of 3. So we're not quite done yet. So I'm going to do 3 times 10 and 3 times, and I forget what that is. So I'm going to go 111 divided by 3 on my calculator. It's 37. Okay, so then I can write that in. So it's going to be 3 times 10 on top, 3 times 37 on bottom. 37 is great because 37 is prime, so I know I don't have to go any further. So there it is.